We are closing in on the finish line here, folks. We are now on Module 13, Lesson 6. Probably going to be Part 1. They claim this is going to be a 2-day lesson covering similarities and transformations. There's going to be 16 resources, so it's going to be at least 2 videos, I think, to get through this one. Russian nesting dolls, also known as Matriashka Dolls, yeah, I probably said that wrong, have been around since 1890. These are sets of similar wooden dolls of different size that are placed inside one another. A drawing of a set of Russian nesting dolls is shown. What kind of transformation might be used to map the largest nesting doll to the smallest nesting doll? Well, in my mind, that is going to be a dilation, where it is a reduction in size. Let's keep going and see what else they have for us today. In a dilation, the scale factor is going to be the ratio of the side lengths of the image to the side lengths of the pre-image. We've already done some work with this. When the scale factor is not equal to 1, the dilation changes the size of the figure, but does not change the shape of the figure. We've already learned that. If the size is changed, the image and the pre-image are not congruent, and we've already learned that as well. Set the scale factor along the number line of the dilation for rectangle ABC. D. So here, if we set the scale factor to 0.5, that's going to give us a smaller rectangle for our prime rectangle. If we take and do it at 1, that means that our new rectangle is identical in size to the previous rectangle. 1.5 and 2. We've learned all about this already. Shouldn't be any great revelations on this part of the information. Now, you can show that 2 figures are similar if the second can be attained from the first by a sequence of dilations and congruence transformations, such as translations, reflections, and rotations. There's a vocab term. I think that's the longest definition of vocab word we've had all year. Since the dilation does not change the shape of the figure, the image and pre-image are going to be similar figures. And similar figures means that the ratio between the corresponding sides is equal, and the corresponding angles are all going to be congruent. The graph of the parallelogram E prime, F prime, G prime, H prime is dilated, the dilated image of the parallelogram E, F, G, H. The prime one can be mapped onto the parallelogram E double prime, F double prime, G double prime, H double prime using the translation 3 units right and 8 units down. So what does all that mean in English? We started with baby blue here. Then we made it bigger going to the green one, our prime, and then we can translate it by going over and down to get to the double prime one. Because this one, the green and the orange, the prime and the double prime, those 2 are going to be congruent in size. Now let's watch an animation to see how 2 figures are similar.
Triangle A, B, C, and triangle D, E, F are shown on the coordinate plane. You can determine if the 2 triangles are similar by using transformations. First, determine if triangle D, E, F is the dilated image of triangle A, B, C. Write ratios comparing the lengths of each side. The ratio of side D, F to side A, C is 10 to 5, or 2 to 1. The ratio of side E, F to side B, C is 8 to 4, or 2 to 1. The ratio of side D, E to side A, B is 6 to 3, or 2 to 1. The ratios are equal. So triangle D, E, F is the dilated image of triangle A, B, C using a scale factor of 2.
Let me pause for just a second. In this problem, all they have looked at so far is going to be the side lengths, comparing the side lengths, and that works for triangles, only triangles. If it's anything other than triangles, you have to also compare the angle measurement. Let's keep going.
Dilate triangle ABC with a center of dilation at the origin and a scale factor of 2. Next, reflect triangle A prime, B prime.
Okay, stop right there. What did they just do? They multiplied each of the coordinates in each part of the coordinates, the A, the B, and the C coordinates, both are X and Y, by that scale factor of 2 over 1 or 2, and that's how they got to the A prime, B prime, C prime. They dilated it out. Let's keep going.
Lastly, translate triangle A double prime, B double prime, C double prime down 10 units and to the right 1 unit so that it maps exactly onto triangle DEF. So, the triangles are similar because triangle ABC can be mapped onto triangle DEF using a sequence of a dilation, a reflection, and a translation.
All right, let's talk about what they did. First thing they did is they found the corresponding sides and made sure that they were going to have congruent or equal ratios, and all of them came out to be the same 2 over 1 ratio. They applied the 2 over 1 ratio to the coordinates for ABC to get to their first prime triangle, where they dilated it out, made it bigger, then they reflected it, and then they translated it. So it was 3 different steps they had to do to work through this problem. Let's keep going and see what else they have for us. Nothing there. Time to get into example number 1, which says, are the 2 figures similar? If so, describe the sequence of maps the sequence that maps triangle DEF onto triangle GHI. So once again, we're starting with the blue, we're going to the green. You with me so far? If not, explain why they're not similar. So let's get going here. First thing we need to do is we need to compare the ratios of the side lengths. And they've given us all of them already lifted here, so they're going to take and compare GH, which is this side length, this leg of the right triangle, to DE, this leg of the right triangle, which gave us a 4 over 2 ratio, otherwise known as 2 over 1 or just 2. The next one, side GI, that's the one that's sitting, the green one sitting on. Side DEF, that's the one that the blue one's sitting on. That's 6 over 3, also known as a 2 or 2 to 1 ratio. And finally, side HI is going to be 10 units. Side EF is going to be 5 units. 10 over 5, that is still a 2 over 1 or a ratio of 2. That's the first thing we had to do. So right now we know that they are going to be similar so far, in that the corresponding sides are going to be congruent. Next thing we have to do is go ahead and expand it out. And expanding it out, that means we're going to have to take and multiply every point in triangle DEF by a scale factor of 2. So in doing that, we're going to select a translation, and this time we're going to do a dilation by a scale factor of 2, and boom, that's going to be the new points you see here. And it even went off the map. That's okay. Now that we have our dilation of a scale factor of 2, what do we need to do? Well, we need to take this, I like doing the right angle point. I'm going to go down 1, 2, 3, and right 1, 2, 3, 4, 5, 6, 7. So I'm going to add another piece, and this time we'll do a translation where I'm going to go right 7. So let's put in a 7 here, and a down 3, so that's going to become a negative 3, and boom, now we should be right on top. And did it actually move it? It didn't. It did move. You can see the orange sitting there on top of the other. So right now, see if I go back. Yep, see, it's there. So we have a perfect covering of the two of them. That means that these are going to be similar figures in size. They're not congruent figures because the original is smaller than the new one, but they are indeed going to be similar figures. So continuing with answering the questions, the dilation with the center at the origin is a scale factor of 2, because we had the scale factor difference we found was 2, followed by translation of, I think it was, what was that? 7 units right and 3 units down. 7 units right, I think, and 3 units down. Gave us the new one. Yep, that was it. That's the answer to that question, and that's all there is to do in example number 1. So now we're going to take and reset it, and we're going to jump on into extra example number 1, where you have to find your scale factor. After you find your scale factor, you're going to dilate it by that scale factor. After you dilate it by that scale factor, then you're going to have to reflect it or translate it or rotate it or something to find out if the two truly overlap and become similar figures. The first thing I have to do is find the ratio between my sides. The prime figure is going to be DEF. The original figure or pre-image is going to be ABCD or ABC here. So from here, we're going to start off by taking and finding out whether or not they're going to have similar sides. And I'm only going to work the 2 sides I know. That's enough. One side technically should be enough to get a good start, but we're going to do the 2 sides I know. So we're going to do the new side, DE over BA. So I'm going to do DE compared to BA. DE is going to be 3 units long, while BA is 1, 2, 3, 4, 5, 6. And that is going to simplify to be a ratio of 1 to 2, or a scale factor of 1 to 2, or 1/2. Next, I'm going to take and compare EF and CB. So I have EF is going to go on top, CB is going to go on the bottom. EF is going to be 3 units long, while CB is going to be 1, 2, 3, 4, 5, 6 units long, which also is going to give me a scale factor of 1/2. That's what we're going to dilate by when we switch back over to our screen here in just a second. I'm going to start off with a dilation of a scale factor of 1/2 or 0.5 maybe. There we go. Now we got it smaller. So we have gone from the big blue down to the little green in the prime. And now all I think I need to do to finish this is to reflect it. So I'm going to take and add another piece here. I'm going to do a reflection across the x-axis, and when I do, it landed perfectly on top of the other one. So the answer to this question is yes, these are going to be similar figures. Come down here. Yes, it is similar. Check. That answers. And then what did we do? We did a dilation by using a scale factor of 1/2, followed by a reflection across the x-axis. That would be your explanation. I think we're going to end part 1 here. We're going to come back in just a minute to part 2, where we're going to start on example number 2, which wants to find out whether or not these 2 rectangles are similar. I don't think they are, but we're going to find out.